Just null hypothesis and alternative.
Okay. So
So the first would be null,
the
right?
null, yeah, the null is that there is no difference, and the alternative is that. What are the options for this one?
Dependent variable, the factor, and then the different levels of the factor.
Okay, so there's 3 different age groups. And the age group is what's in the next one here?
Same thing.
Same
Dependent
thing.
variable, factor, different levels of the factor.
The age group is okay. So the unfortunately, I don't think in these terms anymore, so I do have to check, get some online resource help here, because I want you to get the right answer too. So let me check and see if I can find this.
Chegg says the age group is the factor, the treatment are the different levels of the factor.
That seems reasonable. So that's what I was gonna suggest. Do you know if it's got a thumbs up on it? Looks like it's 22 thumbs up on this one.
It says true. The comments say all correct.
Yeah, the comments aren't helpful. There's a thumbs up and thumbs down.
Oh yeah.
But those are where you should really look, because the comments are, people sometimes they don't realize like theirs is slightly different, and then
there's 26 thumbs up.
yeah, I think this is a good one to go with then.
Except I don't know the ones that like the check mark one.
Yeah, which of the following might contribute to between treatment variance? These they're going to be individual differences in, let's go back and actually look what they're talking about. In the number of drinks per drinking binge. Was there more to this than up at the top, or is this totally the top?
That's the top.
Okay. I think it's only the individual differences, but I don't know whether this is about amount or frequency. Let me read it again. Amount of drinking. So I think it's just this one, because it says the amount up here. It's not the frequency. Okay. But I'd like to, I mean, that's why, as you know, you got to redo the whole thing if you don't get the grade you want on it. So
should I just try it?
Let me just one more. So sometimes what I do when I've helped people with this pass is I've actually just searched for this line right here, and sometimes you get some good hits on just that.
Okay.
And that's sometimes even in like Quizlet or Course Hero.
Yeah, individual differences in the number of drinks. That's what I got on Chegg.
Yeah, I think that's reasonable, but you know, I mean, so it's up to you ultimately. It's your what you're doing there. So we can always come back to it, but looks like we should move to question 3 next.
Okay. Oh yeah, it was all 3.
Okay.
That's fine though. I can just come back to that.
Yes.
Later.
Since you're keeping the highest, you often will eventually get one that is exactly the same as well.
Yeah.
All right, so number 3, we're just looking at the picture here of these. Let me snip this in. All right, so which data set appears to have more variability between treatments than within treatments? Yeah, I mean, like, yeah, I would tend to agree A, because these are here and those are there. The data, good.
The first drop down is substantially larger than 1 and then close to 1.
Okay, so the relative slave ratio in your study is likely to be that, if the between is large relative to the width in. So the F is, and I gotta go look, is it's either S between, S within.
Yeah.
I don't remember which one it is, but let me go, I just check real quick. All right, yeah, so it is, wait for it. Yeah, it is between over within. So since the between is larger over the other one, that means that it's gonna be much bigger than 1. So greater than 1.
Suggesting that null hypothesis will be rejected or will not.
Whenever it's much bigger than 1, it is rejected.
Okay. Yeah, that was 100%.
Okay, so 3 looks like 5 is next. 5 has a few pictures. Okay. All right. All right, the sum of squares between groups, within groups, degrees of freedom, mean square. Okay, what are the options for this first drop down, if you've got them?
8,000, 10,000, 389,550, or 12,000.
Okay. All right, so let me, so the one of it, I mean, we're gonna get this here, but
I have all the equations.
it's not help. So we're adding up some of these. I got to figure out which numbers to add up, and then degrees of freedom. It's either groups -1 for, I believe groups -1 will be the second one. So there's like 3 groups. It's gonna be 2 for the second one. The other one is number of observations total minus groups -1 or something like that. You can, if you want to check there, I'm gonna look also here, and the sum of squares here, I got to figure out which numbers to combine here also. So because sum of squares total is well, they're not given. Okay, let me just do a quick search on this as well. And then this one also, again, it's probably like word for word in Chegg, so just keep that in mind too. Numbers might be different. You just have to figure out how yours maps to that. Okay. Let's see here. It looks like we have to calculate the average of the 3.
For sum of squares within, my formula is just adding all of them up.
Okay. I was gonna do some other things here that, let's see here. Yeah, the within, you add them all up. That's right. The between is more complicated, I guess.
The between is the between is more complicated.
Yeah, so I'll help out here with the between. So to do that, we have to take the means. We have to find what's called X bar bar, and we take the mean. So we take 610 plus 600 plus 590, and we do 1/3 of it because there's 3 of them. That equals 600. Okay, so then we take the n, which is 40, and we take 610, the first sample mean, subtract 600, square it, plus 40 times 600 minus 600 squared, plus 40 times 590 minus 600 squared. So this one is 10 squared, that's 100. 40, so we have 40 times 100 plus, this ends up being 0, plus 40 times 100 here. So it looks like it is about 8,000. Is that an option for the sum of
Yeah.
squares?
Yeah.
Okay. Thank goodness.
And then degrees of freedom.
So the degrees of freedom is it's the number of these groups. So there's 3 groups. So K, if you will, is 3. So it's 2, 3 minus 1. And then the within, you got that number there. And then you're it's the number of observations. So it's 40 minus 1 times 3. So it's whatever, 127, no, 117. Is that an option?
Yeah.
Okay. And then the mean square you get by dividing. So 8,000 divided by 2. So hopefully 4,000 is an option there.
Okay.
And then this one is
2650.
sure, if that works. I don't even know what that is. So I want to add all those up.
Yeah, that's right.
Okay.
Then,
okay. So why have the total? It is sometimes called the error term, I believe. No, that's no. I don't know why you would. Total is easier to calculate. That's true. The first one seems true, but I guess I want to check that with some other things here. Again, you might just search for this last line in a web search. That may help clarify some of this.
okay.
I am seeing it's probably A again here, 4 thumbs up, but I know there's this, so there's more here. Let me go grab the other one. There's another part of 5. Oh no, is that 5? That's the same.
Yeah.
Okay, I thought 5 had 2 pictures. Yeah, so there we go.
So I think 5 does have.
Oh, there's more. In the ANOVA test, there it is. There's more. But wait. In ANOVA, the F test statistic is the blank of the between, I don't know, it's like division ratio in here.
Yeah, ratio.
Okay,
The
So
value
that's,
of the F test, I don't know. That gives you 4 numbers.
oh, so it's this number, whatever is here divided by that one, 4,000.
Okay.
I guess I can,
Yeah, I got it. And then
okay.
null hypothesis is true. F statistic is close to 1.
No, oh, when it's true. Yeah, when it's true, it is close to 1.
And then when it's false, it's close to 0 or large.
Large.
Okay. And then in general, you should reject null hypothesis for large values of the F statistic.
Yeah, that
Value
sounds right. Large
close to
values
1
of
or
F.
close to 0.
Large values of F.
Okay. Okay. Yeah, that was, I got 3.5 out of 4. That's good enough.
Okay. Okay, so what's the next one that we should look at?
6.
6. Okay. All right. To that there. 6 has, okay. This is like working backwards. So let me snip this in. All right. So if there's 4 groups with 6 participants, the within, see, these are out of, I don't know why they do this to you. They're out of order. That's because so the within and between, no, I guess they're not. So the between is the that's not right either. Oh, okay. They're not giving me SS. All right. Never mind. I'm sorry. So between, there should be an option for 3 because it's 4 minus 1 is the between.
Okay.
The within is the number of participants, okay, minus 1 times K, which is 4. It also has to add up to 23, so that means that's 20.
Okay.
Now there's more to this one, I guess. This thing they're giving you down here, like you're supposed to change this number to 3 and then this number to 20, and this changes. But I don't, let me see what you're doing here next. You are, oh yeah. All right, so at alpha equals 0.05, the significance, the boundary of the critical region is, so what you're trying to, I guess you're going to change this to 3 and this to 20, and then you want that number right there to be 0.05, and see if you can come up with this number there. I will do the same in another tool.
Okay, yeah, I got it. 3.098. So 3.0. Wait. Oh yeah, 3.098.
Yeah, I got that as well. Got that one right there. And then 0.01, you just change that number to 0.01. Oops, 0.01. Sorry, the wrong screen. And should get 4.938.
Yeah. And then there's like one more part. Yeah.
At the 0.01 level, your conclusion is, so what you have to decide is where does 3.95 fall? So here's the picture. Like this is like the only thing that really matters in this whole course that they want you to take away. 4.938, and your value is right there at 3.95. This is the reject region. this is the not reject region. And you're in the not reject region because 3.95 is less than the reject. So cannot be rejected.
Okay, yeah, that got 100%.
Great. Seven. You sent B, C, D.
So yeah, the one that has no letter is the first 7, and then yeah, B.
Okay, let me go find it. There it is. Okay. All right. I'm going to keep that one up on my screen, but I'll snip in 7B. And I'll try to tell you the numbers.
Okay.
Or yeah, there it is, B. Okay, you plan to use an ANOVA to test the impact. Okay, what is the null hypothesis? They're all equal. So looks like it's that one. They tend to always be all equal.
Okay.
Now, because they give you the total and they give you the within, the between is the total minus the within.
Okay.
So get a calculator, grab that number there.
Okay, yeah.
What's the, can you give me that number?
270.86.
Okay. The degrees of freedom between, so there's 3 groups. There's cola, black tea, and coffee. So that means that there's 2 groups to K minus 1. K is your groups 3. So 3 minus 1 is your there. And then they tell you that there are 7 per, or 7, I don't know, 7 per group. So you take 7 minus 1, and then you multiply by the K value, which is 3. So you get 18. And then that should be 20 should be an option there. It's always N, big N minus 1 there.
Okay.
So you only need to know enough to do the part of the table that you don't know without either adding, subtracting, or dividing. Because the MS you get from, you take 270.86 and divide it by 2. Then you take 702.28 and divide it by 18.
Okay. All right, got that.
Okay, so then the formula for the F ratio is, so it's whatever number you got here goes in this. So whatever number is there goes here, and whatever number there goes there.
Actually, it's variance due to chance, variance due to both chance and caffeine.
Of course it is. It's not something straightforward. I get a variance due to chance. But this is like a purely like go see if we can find it somewhere online here.
Okay.
So I will look, tell you what I think. You may want to just search for this using words chosen from the drop down menu. That may get you the hit that you want for it.
Okay.
So I'm seeing the chance and caffeine over the variance due to chance with let's see how many upvotes this is getting. Lots of upvotes. Okay, so I'm tending to believe that. So it's chance and caffeine over just chance.
Okay.
And then I guess we can go to 7C. We can see what's there.
And then for F equals again, would it be what you were saying before? Like,
Yes.
okay. Okay, and then it says F 135.43.
So it's whatever 135.43
Yeah.
divided by whatever that other number is. Get that there. And then in this picture, your top number, it's the top number in the table. It's the 2 and the degrees of freedom. This is really 2, and this is really 18. And then it'll give you a line here, and you want 0.05 in the tail, the right tail. So you need to change it to that option there, I believe. Also,
Two-tailed or one?
One tail. F distributions are always
Okay.
one tail. Well, not always, but
And then 0.05.
yeah, I'm not even sure you need the I don't know that this part is graded, but we're going to use it for part D, which
Okay.
is deciding whether to reject or not. So let me get the critical value and then tell you what I think it is. We're doing 0.05 and 2 and 18.
I got 3.555.
That's the that's the deciding point. So
Oh,
what is this number right here?
3.47.
Yeah, so 3.47 is less than that. So you cannot reject. So it's either B or C.
Okay.
You do not. Yeah, I think it's B. You do not have enough evidence to say that caffeine affects test performance. I would go with B, I guess.
Okay.
You can also search the answers themselves. That will probably also get a hit. This hasn't changed in like 10 years or more.
Okay.
Seriously, I've been doing this a long time where people, it's the same thing over and over again.
It's brutal.
Does that
Yeah,
take care of 7? Looks
we
like
do
it.
not. Yeah, I think you're right. Yeah, that got 100%.
Great. Okay, so it looks like 9 is possibly next.
Yes.
9. The way you did this, where you put the numbers in here, is really helpful. A lot of people wouldn't have done that. It would have been very, very hard to navigate. So thank you for doing that.
Yeah, no problem. I figured it'd be difficult. I was getting like off track, even screenshotting them.
Yeah. Okay, for the findings. Okay, so again, another ANOVA. We're doing ANOVA. Okay. Simple measure of the effect size is given by, what are the options here?
Some like weird like n squared number that's not really an n.
Eta squared.
And then
Maybe.
is honestly significant difference test, Cohen's D, and the chef test.
So I believe it's this. I probably would just search this right here and do it. And let me look, because we got to use it for the next one. These are so unhelpful. No one ever asks you for this information later on, like another class, but. So eta squared is looking like it's the right thing. Cohen's D is something else. So it does SS between over SS total is what I'm seeing.
Okay.
So then based on that, and sometimes like we can check here. So it's taking this 3,095 divided by 212,339.66. And hopefully that number is there. That's another sort of possible check here. A lot of upvotes on that one.
So what is it?
It's taking this number right here and dividing it by this number there
Oh,
for
okay.
this.
Okay.
It should be pretty small, like 0.0 something.
Is it the 212 number over the 3?
No,
Divided-
it's between first. It's the 3,095 over the 212.
Oh, okay. .0145.
So there's 0.01 in there.
Yeah.
All right, and then the percentage of variability in scores accounted for by the effect due to the treatment is 1%. Yeah, should be this or that. Okay, so that's 9 first picture. And then is there
Yeah,
more?
that worked.
Is that
That's it.
all of it? Okay.
Well, wait, is 10 in there?
10 is next. Yep. I was just making sure we got everything for.
Okay.
I see 10 without. I see 10B. That's probably everything we need. Yeah, this is all we need. All right, so F, you take the 1211.04 right next to it and divide it by 157.63.
.68.
Okay, is that in the drop down there?
Yes.
Okay, so the numerator is this number and the denominator is this number. So you put 1 there, you put 34 there, and alpha is 0.05. So in the right tail, you want 0.05. I guess that's the number you're pointing at.
0.05.
Okay, and then the critical value will appear, and I can find that for you as well.
So then 4.130.
Yes.
That's a drop down. Okay. And then
Okay, so then that takes care of 10B. Let's see what else is here. 10C. All right. Now evaluating the null hypothesis, the population means for all treatments are equal at a significance level that the null hypothesis. Okay, so you're comparing the number you just found, 7.68 to 4.13. Since it's greater than the critical value, you reject the null hypothesis. You
okay.
find that something
You can or cannot conclude.
can, because you're rejecting. Now you decide to use a t-test to test that there's no difference between groups. The estimated standard error is 4.19. So the test statistic is, do we have means?
Yeah, the means are I think they're at the top. There's a mean. There's two means, away facing and parent facing.
Okay, so we need the difference between them. Let's
Okay.
subtract.
104.3 minus 92.7.
Like that.
The difference is 11.6.
Okay, so it's 11.6 divided by the standard error, which is that number right there. And that number should be in the drop down. So 11.6 over 4.19. Hopefully that number is there.
It is, but it's negative 2.77.
Okay, that's fine. I didn't know which order to subtract.
Okay.
So that's reasonable. Now the degrees of freedom, we have to know how many were in the two groups.
Um,
Oh, there it is. No, 30, no, that's not. We need like n. So to do the t-distribution, we need like the number of pairs that made this up, each one of these numbers.
oh, there's 18 newborns each group.
Okay, so we'll go 18 minus 1, so we'll go 17 for that there. And then you want 0.025 there and 0.025 there. And I will also do this. So I get like the number should be minus 2.110 and then positive 2.110. Are those options here?
There's 2.032. That's the closest to that. Oh wait, 2.728.
None of those seem right. So you said there's 18 per group?
So at the top, it says you randomly assign 18 newborns to parent-facing strollers and 18 newborns to away-facing strollers.
Okay, so let's try this one. Let's go 18 plus 18 minus 2. So that gets you 34. Does this slider go up to 34?
Yeah.
Okay. And let's see what we get there. I get 2.03 plus or minus. Did you say? I think you said that was on there.
2.032. Yeah.
Okay, so that is on there. So now there's probably asked whether to accept or reject.
Yeah.
Is there a 10D picture that you sent? Let's take a look. There it is, 10D. Okay, so 10D. Snip that in. Okay, so your number is minus 2.77, which is left of 2.03. So that means you reject.
Okay.
So it's like your critical is at minus 2.03, but you're there at minus 2.77. You find that you can conclude
Yeah.
when you evaluate meters, the ANOVA has resulted in.
And then the last one
same.
is the same or a different.
So we said can conclude up here because you rejected from the ANOVA. So we said can here. You find that you can conclude influences. They and the same result here. You might, yeah, I think that's probably check.
Should I check it?
Yes.
Yeah, that's right. Okay. So I mean, we have 7 minutes, but I guess we could try to redo number 2.
It's if you'd like. The process will be about the same. You'll need to send over a picture and then we can look at it together.
Okay. Okay, yeah. I will send it right now. All right, I sent it.
All right, let me take a look. Okay. The blank is that at least one of the population means is different from the other. So the first one is the alternative.
Okay. So the only thing we got wrong with this one was the bottom part on the last problem.
Yeah. So
Yeah.
it depends on whether it's between or within, like yours has within. So, but the first one is alternative. The second one is null. Hearing aid type is D factor. I think we said factor for that first one.
Yeah, it's factor and then the different levels of the factor.
Mhm. So the question is whether, like, which of the fund might contribute to between treatment, and you're now looking at within treatment. So there's some change, there's something, slightly different about that. So I'm just gonna, I guess I'll just look. I don't know what it is. So let me check here. So it's definitely individual differences for within.
In a person's response or in the severity.
Well, it would be both because it's within that particular group. I mean, I don't know what to tell you other than like try this and then remember what it actually is, and then the next one will be one or the other. So for
That
between,
worked. It worked.
great. Okay. Glad we got through all this.
Yeah.
Be happy to help again. If your exams are probably going to be more like whatever you had up until now. I don't know how it depends on the class you're taking, but sometimes they're not like this. They're just multiple choice stuff. Some are calculations.
Yeah. Okay. I'll probably schedule again. Are you gonna be really busy with like finals coming up?
I am. So if you ever see a time or if you need a time, you don't see one, just text me and I'll see what I can do to help accommodate you.
Okay. Thank you.
You're welcome. Bye now.
Bye.